Hi all, welcome back to Malware Analysis. I'm Jay Lavanya, Assistant Professor of CSE Department. So today in this video, we are going to discuss on the topic called Malware Analysis. The subtopic is PE file types and header analysis. So let's dive into the topic. So first of all, what is meant by PE files? So PE file is nothing but it is a portable executable files which is commonly used in Windows for executables or for DLL link, dynamic link libraries and other code which are analyzed for malware detection and by examining the header information and section details. Okay, and this static analysis technique helps to identify the malicious files by revealing the metadata, code, and data characteristics indicative of malware. Okay. And apart from that, we have something called the PE file types, and this is a static analysis technique. Okay. So whatever we have defined in the header or the file type which have been mentioned in the sense, it will be most probably used. Okay. And this understanding the structure or it has some standard file format, right, for executable code or for object code or for DLL and other files on the Windows OS. So understanding the structure, particularly the header information, is crucial for reverse engineering. Okay, and what are the key components of a PE file? Includes the DOS header, and which contains a DOS stub, a small program that runs if the file is open in MS-DOS. Okay, can you able to understand? Yeah, and a pointer to the PE header. And this PE header includes the PE signature, which identifies the file as a PE file. And the COF file header and an optional header also has some specific rules and regulation which has to be followed. And there is some optional header which contains some critical information like the entry point, image base address, and the section alignment. Okay, and in section headers we have to describe the different sections within the file such as dot text or dot data or dot rsrc, specifying the sizes, locations, as well as the attributes. Okay, now let us see what are the PE file types available. So first one, .exe, we all know that's a standard executable file that programs that can be directly executed by the operating system. And second one, that is DLL, that is dynamic link library file, and is shared libraries that contains the code and data which is used by the multiple programs. And next one, the .sys, this is a driver file, and next file is the .ocx, that is the ActiveX control where it is used in some various components. And next one, .cpl, that is a control panel component. So these all comes under some object files. It is an intermediate files that is generated during the compilation process, which contains some compiled code and the data that can be linked together. Okay, and then .scr is nothing but here the screensaver, and .drb, it's a legacy driver files. Okay, and other types, it includes various file types like as we told. So these are some the most commonly used file type is that executable file as well as the dynamic link library file. Okay, so this is a PE file structure. So as we have discussed, here it contains the DOS header and the stub and PE signature and CO COF, or we used to say as a CFF Explorer, right? That is a popular tool for analyzing the PE file headers as well as the sections. Okay, and then optional header also there is a there, and section tables as well as the sections. Okay, and there are some file structure where it uses some format like in Microsoft also they have defined these formats. And what they have informed is that there is some specification there. We have to follow some the set of attribute certificate or the date time stamp or the file pointer, linker, object file, some reserved words, relate to virtual address, something like that. Okay, so all these things comes under this stub. Okay, that is the file structure. So this is a file structure that it contains the DOS header and the stub. Second one, the PE signature. Third one, the COF as well as the PE file header. And the fourth one is the optional header. And the fifth one is the section table. And last one is that the sections. Okay. Now we will see a diagrammatic format of the PE file structure. And this is a file structure. Here we can see the header and the sections, right? In the header, under the header, we have the MS-DOS header, PE header, and optional header, sections tables, and import or export address table, right? So the initially there is the DOS header, right? So this, this DOS header. So this is a very, very important question, okay? So this DOS header, it initially has some 64 bytes, like starting with some MS, like Max Suboxky, which contains a pointer to the PE header. Okay, and PE header, that is next one, like it has some NT header. Okay, so this NT header contains the PE signature or the file header, like image file header, and optional header, like image optional header. Okay, and next one, like file header, it has under this there will be some which provides information about like mission type and what are the number of sections as well as what type of timestamp they are using under this particular file header. And similar to that, in the image optional header too, it includes some entry point or the image page and section alignment details. Okay, and this section header, what it does is that, so here also uh, it includes some size or location and some characteristics. Okay, like characteristics, if you take here, the sections may contain .txt or the data or the R data or the resources from RSRC and other relevant information. Okay, and next we are going to see is about malware detection via the PE header analysis. So what is the main purpose of the PE header analysis? So identifying the analysis or examining the PE header, and it can reveal the anomalies such as unusual section names or the suspicious timestamps or the unexpected section characteristics which can indicate the malicious activity. And compile startup, so where this compilation timestamp to the file header can reveal when the file was created and which can be useful in identifying the potential malware. Okay, and in subsystem 2, this subsystem information in the optional header indicates the type of interface the executable uses. Example like a console or guide, which can be relevant in the malware analysis. Okay, and in the section analysis also reveals the code and data within the file, analyzing the section characteristics such as permission and sizes, which can help to identify or pat or obfuscated malware. Okay. And next one, like import and export. So the import and export table within the section reveal the libraries and functions executable relies on, which can be indicators of the malicious intent. Okay, and so this there are some machine learning approaches where it is used in this file structure. Like machine learning algorithms can be trained to classify this PE file as malicious or benign based on the feature extracted from the PE header as well as the sections. Okay, by through that also we can able to analyze. And next one, the portable, executable format. There is a format. In this format also, which is used for executables or object code and DLL in Windows OS, and it is derived from the earliest COFS, that is Common Object File Format, and it was designed to be a portable across all 32-bit and 64-bit version of the Windows. Okay. And under the section, we have the dot data or the dot R data section, E data section, and I data section, and text section, right? There are so many sections available. Okay, we won't use most probably all those stuff, but in some cases there will be occurrence where we'll be using only a little bit of these sections. Okay, so this is about the PE file structure. uh, Next one, before going to the data directories, right? I'll just show something like what are the header analysis tests. Like in DOS header, there is an image DOS header, which is located at the beginning of the file. Like key fields, if you take like the magic or the DOS signature or the offset to the PE header, okay, and then type the struct also we have the image DOS header or the magic number, file address of a new executable header, or the PE signatures, right? Like 4-byte signature, like it can be known like PE/0 or /0, something like that. Okay, and which immediately follows the DOS stub. And next one, like COFF or the PE file header, and it also contains the basic information about the file. The key fields, like if you take like a target CPU architecture, or the number of sections, or the count of sections, or the time data stamp, which builds the timestamp. Okay, and this file header also, if you are defining within the structure in a C program, it contains some word mission or the number of section or time date stamp or pointer to the symbol table. Okay, and a number of symbols which you're going to use, and the size of optional header, and as well as the characteristics. Okay, and there's an optional header, like as I informed, image optional header. Despite its name, this header is required for executable files which contains the crucial information for the loader. Like key fields also, it contains like P32 or P32, that is 0x20p, an address of entry point or the image base, section alignment, file alignment, or the size of the image, size of the headers, subsystem, DLL characteristics, or the data directories. Okay, so under this optional header only, we are having the option called, this is the important data directory, right? Okay, because without this data directory, we can't able to fetch those information from the PE header. Okay, so that is the main, main thing which we have to use it. Okay, and what is the data directory? So it is a portable executable file, and which is a crucial component that helps the OS loader understand and process the executable. And it's an array of image data directory structure which is located at the end of the image optional header within the PE file. Just now I told, right? So we can just check it out the notes over there where I have described the structure and the well-defined program over there. Okay, and this image data directory structure which contains two key fields, like the virtual address, that is RVA, and this is a relative virtual address that points to the beginning of a specific data structure or table within the PE file. And the size, if we take it's that, it indicates the size of the corresponding data structure or the table in terms of bytes. Okay, and there are totally 16 predefined types of data directories, and each which is identified by index in the array and pointing to some different types of information that is essential for the PE files operation. And some of the most important data directories include like export directory, import directory, a resource directory, or the base relocation table. Okay, and this export directory, and it also contains information like about the functions or the data exported by the PE file, It is commonly found in some dynamic link library. Okay, and if you use the import directory tool, it points to the import address table we used to call as the IAG, and it contains details about the DLL and the functions which is imported by the PE file. Okay, and next one, the resource directory, or we used to say as a resource table, which points to the resource section, which stores the application resources like icons, images, as well as the strings. Okay, and similar to that, we have the TLS table or the load configuration table. So this is what in the data directory is very much important. Okay, and under the like in section table also, there are some array of section headers which follows the optional header, where each section header describes one section in the file, and key fields like name, virtual size, virtual address, size of raw data, or pointer to raw data, as well as the characteristics. Okay, so apart from these data directories also, we have like base relocation table, debug information, architecture, global pointer, thread local storage or the load configuration, bound import or import address table, or delayed import descriptor, or CLR runtime header. Okay, we used to have that type of data directories also, and these are the very important tools for this PE analysis. So first one, there is PE view, which is a simple viewer which is used for from PE file structure. And the second one, CFF Explorer, which is an advanced PE editor. And PE Studio malware analysis, it is free of focus. And dependency worker, it is used for analyzing the imports and exports of the PE. And binary ninja, or it is otherwise called as IDA Pro, where the disassemblers with the PA will be passed simultaneously. And last one, like Dumpin, which is a Microsoft tool, which is used for some command line analysis. Okay. So why we need this PE analysis, right? Like what are the advantages? Because most probably all will be using these kind of stuff, right? But why this in case of thing or something like that, why we are going for these kind of uh, P analysis? Because without P analysis, we can't able to do the structure or the behavior. Okay, so the main advantages of using these kind of tool or the header or section, whatever may be. Okay, the first point is the quick identification of the key feature. That is, the P header contains some crucial information like the file type or the architecture. It can be of 32-bit or the 64-bit set. Okay, and it contains some section names and imported libraries which can help in quickly identify the potential malware. And next one, it is faster than the full file analysis. Examining the PE header is faster than analyzing the entire file, right? Which is makes it efficient as well as for initial triage or the identification of some suspicious files. Okay, and understanding the file behavior, and PNAS reveals how a file interacts with the operating system, such as which libraries it uses and its entry point, and which can be crucial for understanding its functionality. And the malware classification, by analyzing the structure and characteristics of the PE file, malware can be classified to different categories, aiding in understanding its potential impact and developing the appropriate defenses. And detection of packed or obfuscated malware, while not foolproof, PE analysis can reveal signs of packing or obfuscation, prompting the further investigation. Okay, and if you take the drawback, of P analysis and malware thing is that the first one, moral malware often employs a sophisticated method to bypass the static analysis techniques like packing, encryption, or polymorphism, which makes the P analysis less effective. Okay, and false positive, we can't able to commit, right? Now understanding the nuisance of the PE format, And analyzing the data, which requires some specific knowledge and experience, leads to some false alarm and some wasted resources. Okay. And evaluating malware as malware evolves, so new techniques emerges to evade the detection through the PE analysis, and which requires continuous updates to analyze the methods. And this can be bypassed also. And pattern or obfuscated malware can hide its true nature within the PE header, which makes it difficult to detect using the static analysis alone. And we have to reveal the time, because static PNS only reveals the information about the file structure and potential behavior, but not its actual runtime action, which is vital for understanding its impact. Okay, so this is all about the tools for the PE analysis. And next slide we are gonna see is that but before that, there is one more thing, that is malware analysis consideration. So while analyzing the potential malicious PE files, you have to check for the suspicious section name, or whether it is normal or it is masthead is not, okay? And you have to look for some mismatches between the virtual size and size of the raw data. And we have to check for some unusual uh, entry points because the malware, because it's static, it won't reveal the information. Whereas if you're going for some dynamic information, surely there will be the occurrence of malware which occurs through some unusual entry point. And examine the input table for suspicious API, and you have to verify the digital signature if it is present. Okay, if it is not present in the sense, it's not much needed. And check for the path or for obfuscate sections, and it analyze the resource section for some embedded content. Okay. So this is all about the PE analysis. So in this video, we have discussed the topics called what is meant by PE analysis, and what are the PE, that is portable executable file structure, and what are the header section and what are the section. Okay, and what are the common PE file types we have seen, and file structure and header, and what are the different structure, and what are the data types which is available over there. And we have discussed on the topics like advantages as well as the disadvantages, and we have used the tools for PE analysis. So what kind of tools we are gonna use for it, and at last, like malware analysis considerations. Okay, so this is all about this video. We will see in the next video. So thank you all.